Hello friends, I am your maths faculty from QLS Academy and today I am going to start a new topic and that is direct and indirect proportion. Mohan prepares tea for himself and his sister. He uses 300 ml of water, 2 spoons of sugar, 1 spoon of tea leaf and 50 ml of milk. How much quantity of each item will he need if he has to make a tea for the 5 persons? If 2 students take 20 minutes to arrange the chairs for an assembly, how much time would 5 students take to do the same job? We come across many such situations in our day-to-day life where we need to see variation in one quantity bringing variation in other quantity. अब हम कुछ एग्जाम्पल से देखेंगे कि कैसे एक क्वांटिटी में वेरिएशन होने से दूसरी क्वांटिटी में वेरिएशन होता है. फॉर एग्जाम्पल वी विल टेक फर्स्ट. As the speed of vehicle increases, the time taken to cover the same distance decreases. We will take second point. If the number of article purchased increases, the total cost also increases. More the money deposited in the bank, more the interest earned. Here, we observe that the change in the one quantity leads to change in another quantity. We can see some more examples. When we purchase anything from the market, peanut or cashews, then the amount paid increases as increase in the quantity. The cost of the fuel increases with the increase in its quantity. How do we find out that the quantity of each item needed by Mohan or the time taken by the 5 students to complete a job? To answer such questions, we now study some more concept of variation. Friends, अब हम देखेंगे कि direct proportion क्या होता है. If the cost of 1 kilogram of sugar is rupees 18, then what would be the cost of 3 kilogram of sugar? It is rupees 54. Similarly, we can find the cost of the 5 kilogram or 8 kilogram of sugar. Study the following table. Here you can see the table. Weight of sugar in kilogram are 1, 3, 5, 6, 8 and 10 respectively. And you can see the cost in rupees are 18, 54, 90, 108, 144 and 180 respectively. Observe that as weight of the sugar increases, the cost also increases in such a manner that their ratio remains constant. Take one more example. Suppose a car uses 4 liters of petrol to travel a distance of 60 km. How far it will travel using 12 liters? The answer is 180 kilometers. How did we calculate? Since petrol consumed in the second instant is 12 liters, that is 3 times of 4 liter. The distance travelled will also be the 3 times of 60 km. In other words, when the petrol consumption becomes threefold, the distance travelled is also threefold of the previous one. Let the consumption of the petrol be x liters and the corresponding distance travelled is y kilometer. Now complete the table. Here you can see the table petrol in liters. So the values are 4, 8, 12, 15, 20 and 25. And the distance in the correspondings are 60, 120, 180, 225, 300 and 375. We find that as the value of x increases, the value of y also increases in such a way that ratio x upon y does not change. It remains constant. Say its value is k. In this case, it is 1 upon 15. We say that x and y are in direct proportion. If x upon y is equals to k or x is equals to k into y. In example, 4 upon 60 is equals to 8 upon 120 is equals to 12 upon 180 and so on is equals to 25 upon 375. Where 4, 8, 12 and 25 are the quantities of petrol consumed in liters and 60, 120, 180 and 375 are the distance, that is y in kilometers. So, when x and y are in direct proportion, we can write as x1 upon y1 is equals to x2 upon y2. y1 and y2 are the values of y corresponding to the values of x1 and x2 of x respectively. The consumption of petrol and the distance travelled by a car in the case of the direct proportion. Similarly, the total amount spent and the number of article purchased is also an example of direct proportion. Thus, variables increases or decreases together need not always to be in direct proportion. Let's see how. Now we will take an example. The first, physical changes in human beings occurs with the time but not necessary in predetermined ratio. We will take another example, that is second, changes in weight and height among individuals are not in any known proportions. The third one is there is no direct relationship or ratio between heights of a tree and number of leaves growing in the branches. Now you can think of some more similar examples. Observe the following table and find if x and y are in direct proportion or not. You can here see a table which is having the value of x and y. The values of x are 20, 17, 14, 11, 8, 5, 2, and the corresponding values of y in the table are 40, 34, 28, 22, 16, 10 and 4. हम यहाँ पर देख सकते हैं कि रेशो x अपॉन y इज कांस्टेंट थ्रू आउट द टेबल, दैट इज 20 अपॉन 40 इज इक्वल्स टू 17 अपॉन 34 इज इक्वल्स टू 14 अपॉन 28 डैश 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 एंड शो ऑन. वी विल गेट 2 upon 4 is having the same values as 1 upon 2. Therefore, if x and y are in direct proportion, let us consider some solved example where we would use the concept of direct proportion. For example, the cost of 5 meters of a particular quality of cloth is rupees 210. Tabulate the cost of 2, 4, 10 and 13 meter of clothes of the same type. So we will see the solution. Suppose the length of the cloth is x meter and cost is y. Here we can see a table. The values of x and y are given. The values of x are 2, 4, 5, 10 and 13. And the values of y are y2, that is we have to calculate, y3 again we have to calculate, 210, y4 and y5. As the length of the cloth increases, the cost of the cloth also increases in the same ratio. It is the case of the direct proportion. We make use of relation of the type x1 upon y1 is equals to x2 upon y2. Here x1 is equals to 5, y1 is equals to 210 and x2 is equal to 2. Therefore, x1 upon y1 is equals to x2 upon y2 gives 5 upon 210 is equals to 2 upon y2, or we can say 5 into y2 is equals to 2 into 210. That is y2 is equals to 2 into 210 upon 5. That will be is equals to 84. Now we can see if x3 is equals to 4, then 5 upon 200 is equals to 4 upon y3. Then y3 comes out to be 168. Similarly, in the third one we can say if x4 is equals to 10, then 5 upon 210 is equals to 10 upon y4. Then y4 comes out to be 420. If x5 is equals to 13, then 5 upon 210 is equals to 13 upon y5. Then y5 comes out to be 4th. If x5 is equals to 13, then 5 upon 210 is equals to 13 upon y5. Then y5 comes out to be 546. Now we will see one example. A train is moving at a uniform speed of 75 km per hour. The first question, how far will it travel in 20 minutes? And the second question is, find the time required to cover a distance of 250 kilometers. Solution will be as, let the distance traveled in kilometers in 20 minutes be x and the time taken in minutes to cover 250 kilometers be y. Now we can see a table, distance traveled in kilometer and time taken in minutes. The values are 75, x which we have to calculate, 250, and the time taken corresponding values are 60, 20 and y which we have to calculate. We should remember that 1 hour is equals to 60 minutes. Since the speed is uniform, therefore the distance covered would be directly proportional to the time. Now we will see the solution of the first problem. We have 75 upon 60 is equals to x upon 20. Then the value of x is equals to 25. So the train will cover a distance of 25 kilometers in 20 minutes. Now we will see the solution of second problem. Also, 75 upon 60 is equals to 250 upon y. Then the value of y comes to be 200 minutes, or we can say 3 hours 20 minutes. Therefore, 3 hours 20 minutes will be the required time to cover a distance of 250 kilometers. So these were some problems on direct proportion. Friends, this is all for today. I hope you enjoy learning in this session. For further information or you have any query, please contact the link below. Thank you.